This is the unit on coal, so it makes sense to look at coal energy production specifically. To begin with, we need to look at where is the coal. The coal deposits are 10 times greater than the oil and gas reserves combined, totaling 10 trillion metric tons. North America has an abundance, but we've got to watch out for the societal and environmental impacts of the coal usage. So where is the coal? Here in the US, we have reserves of about 256.5 billion tons. The next biggest, or I guess bigger than us by a bit, is over here in orange, which is Asia and Australasia. This encompasses the OPEC nations. As we noted on the map earlier, there were some large deposits up here in Russia, and there's a smattering everywhere else. How did coal form specifically in West Virginia? Well, we had swamps. The swamps got buried. When they got buried, they get compressed. That compression takes the buried swamp material and causes it to form into coal. That formation occurred about 350 million years ago. This is an artist impression of what the area around West Virginia looked like 350 billion years ago. Oh, million? 350 million years ago, dreadfully sorry. Lots of carbon-rich trees and other biomass. Here is a fern impression from that time period found in Pennsylvania. Here is another artist's view of what those plants look like and this area looked like. There were dinosaurs around at that point. These are Dimetrodons. These trees are called calamites. Here is another dinosaur of some sort. So, as we saw last unit, there are different types of coal. You can just have peat, which is the kind of unheated, unpressurized form. If you increase the heat and pressure a little bit, you end up with brown coal, which looks like this. Again, increase heat and pressure, and you end up with subbituminous coal. And increase again, and you end up with the highly desired bituminous coal. As you increase the coal rank, you are increasing the carbon content. So peat only has 60%, whereas up here at the other end, we are at 77 to 87%. The volatile matter decreases, so 53% in peat, 42 to, looks like a 29% in the bituminous coal. The moisture content goes down as you compress it, and the calorific value, so how much energy can you get out of a kilogram, goes up as you compress it and heat it more. This is another graph of the same thing. Here is the amount of energy that can be gotten from the different types of coal. So lignite is able of producing the least. Anthracite is highly desirable because it has the highest carbon content and the lowest moisture content. Here in West Virginia we get bituminous coal primarily, which is the second best, least amount of moisture, and or second least amount of moisture and second greatest amount of carbon. Here is a map of the U.S. outlining what the coal reserves are specifically. So up in Pennsylvania and a little bit here in Michigan, you have the really good anthracite coal. As we said a minute ago, we get the bituminous coal in our area, or West Virginia. Also in Illinois and Iowa, let's see, Nebraska, Kansas, Oklahoma, and a little bit in Missouri is a good region. Out west, there's a little bit of bituminous coal, but primarily it's the subbituminous or the lignite. And down south, it's primarily lignite.